Hello everyone, I am Ritik Agarwal and today we'll learn about Bitcoin scripts. This is a video assignment under the course Blockchain and Cryptocurrency offered in Bello Institute of Technology, Chennai, taught by Dr. Nithyanandam P. Bitcoin scripts. So what is Bitcoin scripts? What is the need of scripts in Bitcoin? Let's see. Bitcoin script is the language Bitcoin uses to do everything it can do, from sending funds from a wallet to allowing the creation of multi-user accounts. To understand scripts, the easiest way is to understand by an example. We'll take the most common script in Bitcoin, which is to redeem a previous transaction output by signing the correct public key. So this is what the output address will look like. The output address is really a script. In this case, the script is going to be of four instructions. So how does the script works and how does it validate the transactions? The secret is that input address is also a script. This This input address script is combined with the output address. Simply just concatenate them and get a script which is to be executed to successfully claim a Bitcoin. So traditionally these two scripts are called script sig and script public key. That's because in the simplest case, the output script just specifies a public key and the input script specifies the signature with that public key. When a transaction is being validated, these two scripts get pasted together or concatenated. They are executed, and if the script runs without any error, it is considered as a valid transaction. The first script is the input script, and this locking script is the output script. So, where did this Bitcoin scripting language come from? It doesn't really have any proper name, it's just called a script, or you can call it Bitcoin scripting language. It is most inspired by a language called Forth, which is an old stack-based programming language. But you do not need to understand Forth for understanding Bitcoin scripting language. The key design properties here were to have something quite simple, compact, but yet had support for sophisticated cryptography. So this scripting language consists special purpose instructions to compute hash functions and compute and verify signatures. This is a stack-based language. In particular, there are no loops in Bitcoin scripting language. Every instruction here is executed exactly once in a linear manner. So just by looking at the script, you can determine how long it will take to run and how much memory it will use. Some of the limitation of this Bitcoin scripting language is that it is not a Turing complete language. This scripting language is designed because the miners have to run these scripts submitted by arbitrary participants in the Bitcoin network. So we do not want them to give the power to submit the script that might have infinite loop or script that might run forever. Now since this is not a Turing complete language, we do not have the halting problem. So any Bitcoin script will surely terminate within a finite number of steps. Now let's start with Bitcoin scripting instructions. The most common script in Bitcoin is Bitcoin transaction validation script. The script where the sender of the coin simply specifies the public key of the recipient and the recipient of the coins to redeem them has to specify a signature using the specified public key. So now let's look at some of the Bitcoin scripting instructions. First instruction is OP-dup. It duplicates the top of the stack. Whatever the input is, this instruction will duplicate the item that is present at the top of the stack. OP hash 160. This instruction hashes the input twice. First with SHA-256 algorithm, then with RIPE-MD 160, which increases the output length to 160 bit and increases the security level of the hash function. OP equal verify. It is used to check the top two values of the stack. It returns 1 or true if the inputs are exactly equal and 0 or false if otherwise. It then marks the transaction as invalid if the return value is not true and otherwise the value is popped out. Check sig. The entire transaction's output inputs and scripts are hashed. It checks the input signature. It checks whether the input signature is valid or not using the input public key for the hash of the current transaction. Check multisig. It compares the signature first against each public key until it finds a match and continues the process for other public keys. It is repeated until all the signatures have been checked. All the signatures need to be matched with a public key. If the signatures are valid, 1 is returned, else 0 is returned. It is a it is built-in support for joint signatures, so this checks multiple signatures within one instruction. Now let's see how does this script gets executed and validates the transaction. So the first two instructions in the script are just the data instructions. These are the signature and the public key used to generate that signature. And these were specified by the recipient in that script sig component or the input script. So executing data instruction is easy in a stack based language. If you see the data, just push it into the stack, and that's the only interaction with the memory that you have in a stack based programming language. There are no variables, there's only a stack, so the only thing you can do to write data to memory is to push it onto the stack. So when the first data instruction sig is observed, it is pushed onto the stack, followed by the next public pub key instruction, which is also pushed into the stack. Now we'll start executing the second half of the string, which is specified by the sender of the coins. This is the script pub key component of the script. Now we are going to actually manipulate some of those values on the stack. So this op-dupes instruction duplicates the top of the stack and takes the value on top of the stack, pop it off, and write two copies of public key back onto the stack. So this duplicate instruction op-dupe says to simply take the values on top of the stack, pop it off, and write two copies back onto it. So we are just going to duplicate that public key. The next instruction is op hash 160. It takes the top value of the stack and computes the cryptographic hash of it. Now the next instruction is just a data instruction which will just get pushed onto the stack, that is public key hash specified by the sender. So now the top of the stack has two values, the hash of the public key as specified by the sender and the hash of the public key that was used by the recipient when trying to claim the coin. Now the next instruction op equal verify, this will check if the two values on top of the stack are exactly equal or not. So assuming that both the public key matches, this instruction will consume those two data items that are on top of the stack. So now we are left with the two data items on the stack, signature and the public key. We have already checked that the public key specified was the right public key, and now we will check if the signature is valid or not. Now the check sig instruction verifies the signature with the public key. So this is where the power of Bitcoin scripting language comes into play. There is just one instruction that lets you verify the signature. So it's easy to write scripts that do signature verification without calling any special library to check the signatures. That's all built into the Bitcoin scripting language. So this checksig instruction will verify the entire transaction that was successfully signed. This will pop those remaining items from the stack and check that the signature is valid. Now, so now that we have executed every instruction in the script and the stack is empty, if there are not any errors, the output of the script will be simple yes. So every Bitcoin script can only produce two possible outcomes. When a Bitcoin script is executed, it either executes successfully with no error, in which case the transaction is valid, or if there is any error while the script is executing, the whole transaction will be invalid and it will not be accepted into the blockchain. So a little bit more about the Bitcoin scripting language. It is very small. There's room for only 256 instructions because each one is given only one bit. Out of these 256 instructions, 15 of them are currently disabled, so you cannot use them at all. And 75 of them are reserved, so they haven't been assigned to any specific instruction yet. They might get added later in future. So there are basic arithmetic instructions. basic logic like if and then, throwing errors, etc. And finally, there are cryptographic instructions like hash functions, instructions for signature verifications, etc. Bitcoin scripts in practice. So as of today, this script is not very heavily used. So if we look at the history of Bitcoin and see what scripts have been used, the vast majority, around 99.9%, are exactly the same script that we saw in our example, in our execution example. A script that just specifies one public key and requires a signature for that public key in order to spend that coin. There are few other things that have some use. So there's multisig that gets used a little bit, and there's special type of script called pay to script hash. There hasn't been too much creativity in terms of what Bitcoin scripts people use, and one reason for that is that Bitcoin nodes by default have a whitelist of scripts, and they refuse to accept the scripts that they consider not standard. Proof of burn. So some of the scripts are called proof of burn. It is a script that can never be redeemed. So if you have a proof of burn script, it is provable that those coins have been destroyed and there's no possible way for them to be spent. This is quite easy to implement. You just have to use the op return instruction, which throws an error if you have ever reached that instruction. Because the error is thrown, the data in the script that comes after op return will not be processed. So this is an opportunity for people to put arbitrary data in a script and hence into the blockchain. If for some reason you want to write your name, or if you want to timestamp and prove that you knew some data at a specific given time, you can create a very low value Bitcoin transaction. You can destroy a very small amount of currency, but you get to write whatever you want in the blockchain, which should be kept around forever. So this was all from my side about Bitcoin script. Hope you all got some idea behind Bitcoin scripts and how it works. Thank you everyone.